my talk to the memory of true explorers, and I think that the picture speaks for itself. The source code for the new version of Export 2 is available from the security website. This presentation would also be available early next week. And there is also a white paper that you can download, basically outlines in great details the work that we have done and the things that we have implemented for Export 2 O2RC1. Well, currently I am the CISO of International Telephone Carrier. I do computer security research on my own spare time. If you remember the Etherleak paper about the friend-petting information leakage, this is a paper I wrote along with Josh Anderson. I also published several papers on IP telephony security and other papers. I'm also a member of the HoneyNet project. The Export 2 project is an open source project which has 3 developers, myself, Fyodor Yarochkin, which is the other Fyodor if you didn't know, Medar Kidrialev, 2 Russians and 1 Israeli living on basically 3 different time zones, which is kind of interesting. What is Export 2? I bet that some of you know. It's a remote active operating system fingerprinting tool. It is an alternative to other fingerprinting tools, and it was voted by several of you, I guess, as one of the top 75 security tools, and it was actually was among the top 50. Why it's so important to use active OS fingerprinting tools and where can we use them or the information they produce? There are several examples illustrated here. First of all, we need the context. We need the context for IDS systems. We need the context for vulnerability assessment tools. And most of us need to build a network inventory. These kind of tools help tremendously in doing these kind of tasks. And of course, there are some other individuals who use the tools for other usage scenarios, I guess. Export 2 project, basically, as I said before, is an open source project. It reflects its developers' beliefs and ideas. We do hope it contributes to the community at large, to the security community at large, and we do encourage people to contribute to the project. We know that several companies and individuals were inspired by Export 2, so they decided to lift some techniques and technologies from it, but they don't even bother to credit us. First version of Export 2 was released 2 years ago at Black Hat 2001, June 2001. It was only a mission statement relying only on several ICMP based fingerprinting methods that I've researched. It was a static decision tree. As I said before, nothing much. Was a mission statement, a working mission statement. Last year at DEF CON 10, we have released a newer version of Export 2, which had several enhancements. We were the first open source tool to implement fuzzy logic. It's a matching, fuzzy logic is a matching algorithm between the probe results we receive from targeted operating systems and the signature database that we have. Again, Export 202 was relying on ICMP-based fingerprinting tests only. Last April, we have released O.1 release. It's really hard when you work with software engineers to bump up the versions. I was like, cool, so we can release a DEF CON 1.0. And they were like, well, you know what, 0.2 RC1 is good enough. So, O.1 release sends RFC compliant packets. There is no more Export 2 in the payload. We went through a lot of bug fixes. We added a lot of signatures, and we also support the IPID equals sent fingerprinting method, which if you want to learn about is outlined on my website. Export 2 O2RC1 was released yesterday, as well as the white paper. This part of the presentation will go through quickly through several issues with active operating system fingerprinting. If some of you or have any question, please raise your hand and I'll stop and answer the question. When we do fingerprinting and we do operating system fingerprinting, we fingerprint the way the operating system, hence the software, reacts to the probes that we send. When we fingerprint a hardware-based device, we fingerprint the way the device's firmware acts to the different fingerprinting tests. This is something that not a lot of people actually understand, and what they're doing is they fingerprint or put in the signature database the brand of the device that was fingerprinted. For example, if we'll try to fingerprint a Cisco 7200 base router and a Cisco AeroNet 1100 or 1200 wireless access point, guess what? They're both using iOS, so they both will be identified the same. If you don't understand how to build your signatures, then at the end of the day, the signatures that you will put inside your signature database will not give you that much of information. For example, another example is Foundry Networks, Net, Fastbig, Iron family. Basically, they all use the same software version, so it doesn't really matter which Foundry Networks device you're fingerprinting. At the end of the day, what you're doing is you fingerprint the firmware version, you fingerprint the software, and that's what's really important. So if the tool you guys are using has a database which did put signatures according to the brand, I guess the results that you will get will be, well, maybe not accurate, but will not give you enough information for you to understand. If your tool of choice is using a strict signature matching, then if it will not find a 100% match between the received results and the signature database, it will not produce any kind of results. It will be extremely sensitive to different environmental effects on the probe target and on the packets that are sent to the target. As I said before, we decided to implement fuzzy logic, which gives us the opportunity to overcome several difficulties in the process of actively scanning a host and actively determining the OS. Another interesting angle is the use of a fixed number of fingerprinting tests. In theory, if we have a fixed number of fingerprinting tests and we have a fixed number of parameters that we examine, and of course they have a fixed number of permutations, then the possible matches will be a fixed number as well. Sure, the possible matches still has a larger number than the networking devices that are out there, but there are several test cases or test models that will fail to provide us with so much needed results. Basically, what they will create is a certain group of operating systems as a result, as the best effort result, and will not be able to give you a certain operating system as one result only, or two operating systems as the final result. This also means that if you want to have a better tool for active OS fingerprinting, you should use a lot of fingerprinting tests that will examine many parameter values. It should be a test that the parameter values should be different among many operating systems that you're going to test. So we were going through a phase of trying to determine which other fingerprinting models do we need. And some of the fingerprinting models that we examined simply did not gave us the expected results. So I remember one of them just allowing us to isolate one operating system only, and it wasn't Microsoft. So it wasn't really something that we thought that it should be implemented that would give us a certain answer or a definite answer about one group of operating systems. The use of a certain fingerprinting niche is a problem as well. If we are looking at, for example, Xprobe 2 VO1, then we are using with that particular version of the tool only ICMP-based fingerprinting tests. It means that on some tests we will fail to provide the much expected result, meaning that we'll be able to tell that this is a Sun Solaris box, but we will not be able to say which version of Solaris is the exact version on the on the machine. If you use Nmap, for example, using most of its TCP-based fingerprinting tests, there are several groups that you cannot differentiate between. Merely XP 2000 and ME comes as one group, and the other Microsoft-based operating systems comes as another. If you take that into consideration and add to that the fact that newly released operating systems do not nearly change the way their TCP/IP stack is being built, then at the end of the day, these tools like Nmap or XPOP2 V01 will not be able to differentiate between newly released operating systems of the same manufacturer. Usually the changes that we can see in the stack would be very little, usually only in one protocol's behavior, and if you're not testing for that protocol, then you will not be able to differentiate between the new version of the operating system from an old one. This is an example. As I told you before, you can see here a run of XPOP2 V01 against a Sun Solaris 8-based machine. You can see that the results that we have received, basically the entire Sun OS based operating systems. This is an Nmap run against an NT4 based machine, SP6A. You can see that we got a lot of other Microsoft based operating system with the results. Another interesting angle to active operating system fingerprinting, which is turning to be a very major issue for all of us, especially in a big corporate network, is the ability to determine the exact software service spec which is installed on a certain operating system. Usually the traditional tools will be unable to uncover the exact service spec installed on a certain on a certain box. It will be able to tell that the machine is a Windows 2K server, but the exact service spec will not be detected. Several other issues include tests that may have bigger impact on the overall results. If they're going to fail, if you will be unable to execute them for some reason, you will be affecting the overall accuracy of the tool, of the result that you will receive, and the much effect that you would have expected otherwise from that particular test will not be actually in effect. This is an example with XPOP2 running all of its fingerprinting models. You can see that the test in question here is a Microsoft Windows XP Pro SP1, but you can see that we got the 2000 as well as the answer. If we omit the ICMP Echo fingerprinting test, we can see that the Microsoft Windows ME based machine is now given to us as a result as well. That's because the ICMP Echo fingerprinting test is being used to not only differentiate between Microsoft-based operating systems to the rest of the operating system world, but also to differentiate between the Microsoft ME and the Microsoft 2000 and XP families. Sometimes, especially on the internet, if we are probing a website or some machine, there might be several effects on the packets that we send. For example, on our local network, we might have different VLANs, and several VLANs might have a better quality of service. It means that when we send a packet, our switch will put a value in the type of service field and send it out. Some firewalls are able to change several field values. For example, Checkpoint NG with Application Intelligence can overwrite the time to leave field value and can do other little things. So basically, when you're scanning, especially on a hostile environment or against a hostile environment, your packets may get to the target a little bit different. That's also holds true when you hit proxies or load balancers. And of course, you don't expect systems to be opened and let you just scan them. A lot of systems are being firewalled, and we expect them to be firewalled. So when you scan or use several tests that use some weird combinations, like for example, if you use a SynFin scan against a checkpoint firewall or other firewalls that are able to do stateful inspection, your packet is not going to go through the firewall. So this also brings another angle to it, that if you are using an OS fingerprinting tool, some of the fingerprinting tools must be legit. It means that when you will initiate the tool and you will send it away, you want to be able to go through the firewall that is guarding the target and to be able to receive the reply. And of course, several system admins, especially on the small shops, go and change several behavior on the different operating systems they installed. There is the NDD command on Sans Solaris, the CCTL on the different BSDs. There are the registry hacks on the different Microsoft boxes. For example, several people like to change the window size of the box if the box is being served as a web server and such. If you are relying on this kind of test and the particular values were changed and altered by the system admin of that box, of that corporate that you are scanning, then of course you will get problematic results that will be affected from this thing. Another very important issue, and I think that even if your tool or the tool you're using is very nice, has this great functionality, and at the end of the day the signature database is corrupt, then there is absolutely nothing that can help the tool. It is extremely important to get the fingerprints out of a lab environment, to get them right the first time, and then it will save you the hassles of thinking, well, what were the exact environment that a certain test that was submitted was performed against. I think that if you do not allow a tight control on the signature database, then at the end of the day what you'll have is a lot of signatures that not only you will not be able to trust, but also your users of the tool will not be able to trust. That is a very problematic issue when you want to propagate the signature database. If you want people to submit signatures and have a larger database of signatures, at the end of the day, if you cannot trust the signatures that the users are being producing, or you introduce some lame signatures into the signature database, then basically the signature database will be corrupt. There is an example for with Nmap with the TCP options. End of line basically should be on the end of the TCP option list. There are several signatures there with the end of line in the middle of the option list for TCP. Another important problem, especially for vulnerability assessment tools, is the inability to identify the underlying platform of the operating system. If you want to exploit a certain operating system and it has multiple platforms it can be installed on, it's extremely important for one to understand what is the underlying platform, because your exploit may or may not work on the platform you are targeting. So for example, if you are running a certain vulnerability assessment tool, and that tool is relying on a certain active OS fingerprinting tool and the platform is not being given, then first of all the vulnerability assessment process will be longer and it might be giving you false results. On a large network, when you want to scan, for example, Class B networks, it is very important to understand what is the limit of the network. It is important to understand that if you will use too many packets per second or too many packets in a certain amount of time, not only the networking devices on your network can suffer from a denial of service condition, but also the target operating systems that you are scanning. So it is important. It's important for such an active operating system fingerprinting tool to have the ability to scan large network and still do not put those network under a denial of service condition. One of the issues that we have talked about for the past 2 years is the ability to control whatever fingerprinting models to use, or the ability to control whatever option a tool has. And we have actually implemented that with the newer version of the tool. Sometimes you are on a different situation, for example, targeting a certain topology from a certain topology, and you can only use certain fingerprinting models. For example, if you target the website, it is more likely that port 80 will be open and port 443 will be open, rather than the ability to send a timestamp or a net mask request to that website. So instead of triggering too many alarms, if they are there, or if you care about them, then you can just use the different models you know that will work, and just spare you the lack of the added value of the other models. Another thing that you would like to have is the ability to switch scanning tactics. It means that if you know that a certain tactic you're using will be blocked by a firewall or by another device guarding the operating system or the box that you're scanning, you would like the tool to have the ability to affect the other parts of the scanning or to switch the tactics. If I know that I'm scanning a website, it's much more likely that, again, port 80 and port 443 will be open. So I would like to direct my tool or whatever tool I'm using to use those ports. And if I know that all the UDP ports will be covered, then why initiating in the first place the models that use UDP? So we have decided on adding several functionalities to Xprobe 2. We have added several new discovery models. We added the ability to totally control the tool's models operation. We added more fingerprinting models. We have now a port scanner. We also have an automatic mechanism to assess the receive timeouts for the different models. And we have also rebuilt our database of signatures from scratch. We use discovery models for several things. First of all, we use them as host detection. We use them for firewall detection. And we use them to provide information for the automatic receive timeout mechanism that we have. I'll talk about it in a couple minutes. We have added 2 new discovery models, things that you already are familiar with, basically TCP ping and UDP ping. What we did here, or what we send a packet, a SYN packet, to the target host. We expect to receive a SYNAC or a reset or no answer at all. And when you send the UDP packet, you either get no answer or get the ICMP port unreachable back. We have added, actually using our -p command line option, where one can specify which ports to use with the different models. These 2 new models will not run by default if the -p option will not be specified. Again, they are being used for also for automatic receive timeout calculation. If you did not know, when you probe a host, the TCP answers and the UDP answers that you will get from that host will be much slower than the answer you will get for ICMP. So if you scan, for example, on a local network, your favorite Microsoft-based machine, then just specify an open TCP port. Get one of the most likely to be open, and use the TCP discovery model. That model will help you after that with the automatic receive timeout calculation. Since we did want to allow the users of the tool to have a complete control over the tool, we have added 2 command line options to control which models to use. First, the uppercase D command line option, which control which models not to use, and the -M command line options, which one can use in order to specify the models to use. If you look at the diagram here, you can see the different models that the tool has and their execution order. As I said before, the TCP ping, the UDP ping, and the port scanner will not be executed by default. All the other models will. Not a lot of people do use our TTL distance information gathering model. It actually can do trace routes and give you the route to the box if you are interested in that. So the first example is for the usage of the -D command line option. For those of you who are afraid that they will not see live examples, I have targeted several sites in France for the demo. So I love them. Here you can see that I have specified a numeric value as well as the fingerprinting module name for the -D command line option. You can use whatever is, whatever you like. If you like numbers, if you like to use the module name, whatever. And here we have targeted the Microsoft Windows 2000 SP3 based machine. And yes, we can uniquely identify 2000 SP3 as well as 2000 SP4. The second example is for the usage of the -M command line option. Here we have used only 3 models: the ICMP Echo Discovery model, the ICMP Echo Fingerprinting model, and the ICMP Port Unreachable Fingerprinting model. And you can see that the tool got 100% success of identifying the Cisco 11.2 based router that we were fingerprinting. Since we have a lot of command line options now to allow you to totally control whatever you're doing with the tool, I was thinking that it's good to tell you how you list them. If you want to list the different models that we are using and the different options and what they can do for you, you can use the uppercase L command line option. It will allow you to list the different fingerprinting and other models that tool has, and will show you the different switches that you can use as the command line options. There is another command line option which I don't show an example for, the lowercase m command line option, which you can specify which or the number of matches to print. Not a lot of people like to have 10 lines of output at the end of the scan, so you can specify whatever you like here as well. One of the other enhancements we introduce is a TCP-based fingerprinting module. Again, we didn't invent the wheel here, but we do several things differently. We decided, after looking at several TCP-based modules, to use a TCP module based on the TCP three-way handshake. You all know the process. You all know what is expected to be sent back. Again, we wanted to use a model that we will be able to use against whatever site, and that firewalls will not drop it. We wanted to use legitimate information inside a probe, and we want to maximize the results that we produce with the tool, with the models. Excuse me. So we are sending a SYN request, which absolutely resembles a Linux telnet request to a certain site, to a certain open port, and we examine the parameters received with the CNAC from that machine. Basically, currently, we're looking for 9 different parameters with the TCP handshake model. Several of them are part of the IP header, and several are part of the TCP header. There is a little twist here. For example, the timestamp value is the only parameter we are currently not examining. But we're about to support that with 0.2. Not a lot of people know, and I doubt if too many know about, that you can able to detect a Microsoft-based operating system according to the timestamp value the machine will send you back. Basically, you look for the 00 combo with the CNAC, and that's going to give you Microsoft-based operating systems. So if you are looking on the web and you want to differentiate between Windows boxes and Unix-based boxes on a very easy manner, what you have to do is to send one packet, get the CNAC back, look at the timestamp values. If it's 00, then even before trying to get to the application layer, you can have the conclusion that this is a Microsoft-based box. The following example shows how the TCP handshake module is integrated inside the tool and what is the effect of the module on the overall results the tool produces. We have used here the -D command line option not to use the model, and you can see that the results that we have produced are all the Sun Solaris machines without no differentiation. When we did use the fingerprinting, the TCP handshake fingerprinting model, you can see that the Solaris 8, as was as a target, was 100% identified, and the other Solaris machines got their own probability. So, to sum it up, the TCP handshake model greatly enhanced the fingerprinting results Xprobe 2 produces, especially on big groups of operating systems that we were unable to differentiate in the past. If you look at the signature database inside the tarball that we have released yesterday, you can see that except for maybe the Linux-based operating systems, the results that will be produced by Xprobe 2 on optimal conditions will give you 1 or 2 matches for the probe that you're using, and that's it. It means that no big groups of operating systems, no big ranges of operating systems. That's 1 or 2 100% matches, and that's it. Since we are relying on several ports to be open or closed, well, one TCP port open and one UDP port closed, we have decided to implement a port scanner with the tool. There are a lot of tool users that have asked for that functionality as well. So we have decided to add a port scanner as a independent module to the tool. It means that by default we will not run the port scanner. We will only run the OS fingerprinting tests, and we'll still use the minimum or the minimal usage of packets in order to produce the results. The usage of the port scanner is pretty much straightforward. Use the uppercase P, uppercase T or U, and specify the port range to scan, and you get summed up results of the open and closed ports and the filtered ports. Nothing new here, but again, if someone wants to use that functionality, for whatever reason, we are allowing it. What it also does, when it will identify an open TCP port and when it will identify a closed UDP port, it then will use them for the TCP handshake module and for the ICMP port on which module. It means that if your port scanner did got whatever port you need for a dependent module, then that dependent module will get the port from the port scanner and will run with the appropriate port, and of course will produce the results that you're looking for. There is a nice diagram here outlining the different relationship between the different P's. You can look at that afterwards if you want to. We've decided to not be, well, idiots and just say, oh yeah, we send 10,000 packets in 1 second and we produce the results in like 3, because that's lame and that will not get you anywhere. We allow the users to specify whatever time interval they want between the different scene packet sends and the UDP packet sends. It means that if you want to be paranoid, ultra paranoid, or whatever, just use the -S command line option, define or put the different milliseconds you want as the time interval between the different scene sent or the UDP packet sent, and the tool will do that for you. Basically, you have option to specify it in milliseconds. If you are not specifying -S, then the default time interval between the packet sent with the port scanner will be 10 milliseconds, and it means 100 packets per second. Now, another interesting issue to understand, when I have rebuilt the signature database and used the port scanner, if you have, how many of you have FreeBSD boxes? Great. So you know that there is a nice option called rate limiting, right? So if you sit down and look at your console with FreeBSD and you use a fast port scanner that produces a lot of good results, you'll see those that message is saying that the box is rate limiting the number of sent packets to the scanner. Everybody has his own niche on how to solve this. We thought that it's better to allow the users to specify whatever time interval differences they want between the different packets that the port scanner sends. And of course, that's an important issue, not producing a denial of service on your own machine. Here you can see an example of a scan that was too fast or was not enough timeout in order to produce an accurate results. Basically, it's we scan an OS. Basically, it's a Linux-based OS here. We scan ports 516 to 520 and TCP ports 20 to 30, and you can see that the last port is being filtered. It doesn't mean that the port is really filtered. It means that we have scanned too fast. So by providing a value for the time interval here of 40 milliseconds, we have basically got the problem away. It's important to understand that on a congested network, the scanning conditions are different. On local network, at your home network, the scanning conditions are different. On the internet, the scanning conditions are different. And it doesn't really matter for you to scan with 10,000 packets in 2 seconds, because actually it will not give you the results that you are expecting. What we also did is, of course, used hashing for the port scanner. It's not something we have invented. It's not something that other people have invented in the last year, if you know what I mean. Something that was invented back in '98 by an Israeli hackers group, and we use that for the port scanner as well. Question, someone? I guess lunch did it for you. Another thing that we have added to the tool is the automatic receive timeout calculation that works for 3 different modules for XProbe 2. It makes XProbe 2 scan an IP address at half a second to 2 seconds only. There are 3 different timeouts for the discovery module, for the port scanner, and for the fingerprinting modules. Basically, whatever discovery module you are using, we will take the longest RTT and we will multiply it by 2, and that will be the receive timeout for the fingerprinting modules. For the discovery modules themselves, we have added a -T command line option to specify their own receive timeout. And with the port scanner, we basically have added a different timeout mechanism. And basically, we'll take the number of ports scanned and multiple that by the 10 millisecond default that we have, plus any time that you have put as a time interval between the packet sent, and we'll add the 2x RTT. Now, if the number of packets received back equals the number of packets we have sent for the port scanner, we will time out before the other timeout will expire. Another thing that we did is we have rebuilt the entire signature database of XProbe 2 from scratch. It means that I had to go and install too many operating systems that do not like Pentium 4 or Pentium 3 or whatever. We got back until, well, NetBSD 1.3 was tough to install. The signatures, as I said before, are tightly controlled. We are introducing new signatures only and if only we can be assured that the signatures were produced in a correct manner. Sure, it means that maybe we'll have a smaller signature database, but it also means that our database will be much more accurate than any other database for any other active operating system fingerprinting tool. Yes?
Do you use the heuristic to cut down on the number of scans that will need to be done against the machine to get a proper ID?
I'm going to talk about it later. As I said before, it's very easy to corrupt the signature database. Our new signature database and the tool is able to uniquely identify 2003 standard, 2003 enterprise, 2000 SP4 and SP3, which currently no other tool does. The signature database includes the entire 2.4 branches, 2.2 branches. That was really fun to install. FreeBSD from 2.2.7, OpenBSD from 2.4, and as I said before, NetBSD from 1.3, and of course many other signatures such as for Cisco X, IIX, and other operating systems such as the software foundry runs and such and such. So, as with previous years, if you don't have any other questions, and there is another part after the demo, we decided to target a nice country that we all love and respect. And no, they did not invented the fries. The Belgians did. And no, they do not use American technology. So, first site that I have decided to look at is the Radio France. I wanted to hear that wonderful, wonderful language that I guess, nearly all of us understand fluently and speak fluently. Radio France is using Linux. Good for them. 2.4, actually the group of operating systems, or the kernels that actually match the operating system Radio France is using is 2.45 to 2.16. Then I decided that I'm bored with the radio. Maybe I'll get higher education. And I went to do the Sorbonne University, which is, well, a university in Paris. Here I decided that I would like to use only several modules with my fingerprinting attempt. I did not use several fingerprinting modules, as you can see here, the usage of the -D command line option. And unfortunately for them, they're using American technology or not. I don't know. There are no French operating systems, right? So they're using Sans Solaris 9 on the Sorbonne main website. After finishing my higher education at the Sorbonne, I decided that I need to search for a nice, interesting thing to do. So I decided I'll look for a biotech company. Found one. And that biotech company is using Windows 2000 as their servers, because this is a good example for the inability to differentiate between 2000 until 2000 SP2 and XP. But if there is a web server there, I mean, what the hell it can be? It's common sense sometimes. After working for several years for that company, I decided I need to move on. I decided I need to love my environment. So I decided I'll check out the environment, the government environmental site. Here is again, no American technology used. And they're using Microsoft Windows 2000 and SP3. I guess they need to upgrade. So, after doing all those wonderful, wonderful websites, I decided that I need to know who is the Prime Minister of France. And again, they're not using no American technology, and they're just being hosted by Akamai Networks. And Akamai Networks use a proprietary version of, they have their own Linux 2.2 version, which they are using. You can see that by playing with the different options, which fingerprint models to use, just using common sense. What do I need to use in order to scan a website? I can get my results more accurate, since, of course, there will be several probes that will be blocked, so why using them in the first place? So what we actually are looking forward to implement with O2 release, and what is really the future of things, although I do think that Xprobe 2 O2 RC1 is a very good tool to use. I mean, after 2 years of development, a lot of research, you can download it and try it for yourself and see for yourself how fast and accurate the tool is. Most of the problems that we have with active OS fingerprinting tools and with tools of such magnitude is the inability to assess the terrain that we are in and the terrain that we are scanning. If we are unable to understand both, then our scanning will be affected and we will not get the maximum results from the scan. So if you look at this diagram, it can summarize what we really need to implement and the things that are currently being developed. First of all, we need to add model dependency. If one model depends on the execution of another and the first model fails, there is no need to execute the other one. I mean, the port will not open for himself, man. I mean, it's not a magical mystery tour here. So, what we're going to do and what we're actually working on now is adding intelligence into the tool, because the tool will not be intelligent enough or will not have any AI if we'll not program it to do that. What we're going to do is to add dependencies to assess our scan in each and every stage. If we do discovery models and we get the understanding that there is a firewall there, we will be able to change different tactics of the tool. We will be able to automatically flip to another tactic. If we do fingerprinting models and the amount of received results, the probed matches, will be a big whole group, what we will do is we will look for the common thing with all of those operating systems, and then we will use a niche targeted operating system fingerprinting test to differentiate between the operating system that we have as the result for the first stage of the OS fingerprinting scan. There are a lot of things that we are going to implement at that stage, and at the end of the day it will give us the ability to disassemble the whole operating systems and give you an accurate results. I'd like to credit the following people that helped us develop several things for the tool. You can get further reading from my website, and if someone have any kind of question I can answer, then that's the time. Yes?
You talked about at the beginning about being able to check things based on the hardware that's used.
Mm-hmm.
Are you mostly just talking about routers and switches and those types of devices, or are you also talking about server boards?
We're going to add several tests that will be able to allow us to tell you the exact platform for several operating systems, not only about the networking devices. Sorry?
Like
JetDirect, actually there is support for a lot of the JetDirect version. HP is a good example for how you do not put signatures inside the database. We're fingerprinting HP according to the JetDirect EEPROM version, and we have like 10 different signatures according to the EEPROM. Any other question? Xprobe can be built on Linux and FreeBSD, and I guess on Solaris as well, but we haven't tried Solaris yet. Yes, Red Hat 9 works. Yes. Currently no, but we will be able to do that. Okay, yes, last question. There is a document inside the Tarball describing how we can add your own signatures, and we are going to automate that as well. Yes? The different tests are not currently weighted, but that will be changed with O2 release. So I'd like to thank you for coming here. I enjoyed. Thank you.